The formation and evolution of our solar system played a vital role in how Earth and the human race came into existence. Since comets are remnants from our early solar system, the Rosetta mission is updating and informing our scientific understanding by studying Comet 67P Churyumov-Gerasimenko. Recently, the orbiter's COSIMA instrument discovered organic material in the form of carbon inside several particles collected from the comet's coma, and the type of carbon was more complex than expected.
This carbon was compared for us with a lot of meteorites material that we had measured with a copy of the instrument on ground, our reference model of the instrument, and we tried to find what is the best match. And the best match is actually what we found in very few meteorites, in the Orgueil chondrite, for example, which is a meteorite which is thought to maybe come from an extinct comet. So that would be the best match. But even in our meteorite collection, we don't have any material looking like what we have at the comet. So this is really special, and it's only on some particles.
Rosetta has detected small organic molecules in the form of a gas, but only these larger carbon-bearing molecules in dust particles. Linking how and where these different-sized organic molecules formed and combined with the comet is ongoing, and hints at comets having a complex dynamic history. Along with COSIMA and Giada, the MIDAS instrument has also been collecting particles, but MIDAS is concentrating on those smaller than 50 micrometers, so small that they can't be seen with the naked eye. And one of these particles had an unusual, repeating, fractal-like structure, seen for the first time in a comet.
This is a little bit a surprise, because normally you would expect that dust growth from the beginning on is fractal. However, then in the process of being incorporated into the comet, the fractal structure should be destroyed by compaction. And so this fractal dust particle must be a survivor of this violent compaction process. And so this is a very special catch.
Instruments like MIDAS and others on the Rosetta mission act as time machines because they offer insights into the solar system's past.
It's really pleasing for me as a project scientist to see how the results we have on Rosetta are being put into context of how the solar system evolves. And in fact, broader than that, when talking to the broader astronomy community, you see that they're considering what Rosetta has done or is doing in other solar system. So saying, well, we see this cloud of dust and gas and we have this context measurements from Rosetta, maybe this is how this planetary system is going to evolve, etc. And also for our own system as well. So it's really, really fantastic to have this data set, and it has massive implications.
Before the orbiter hits the comet and ends its life on September 30th, a number of instruments will be collecting data and taking images during the descent. So for many scientists and students around the world, the end of the Rosetta mission is also the beginning of further new science and fresh insights into our history.